We're over 50,000 subscribers, and it's thanks to you out there. Tune in to the end of this video to find out how you can win some new prizes as part of our 100,000 subscriber giveaway. There are really two ways that you can create a resource on the portal. One of them is over here on the left. You have your list of all the resources that you have pinned here. It doesn't come here by default. They're actually pinned by the user, in this case you. And then when you can go into that specific resource, so in this case, for example, we go into the Azure Function App, and then within that Function App, we basically create the resource. When you do it that way, it directly takes you into the creation experience, the wizard for creating that resource. Alternatively, you can, for example, go to the resource group, and from the resource group, you then select that you want to create a resource. And when you select that you want to create a resource, what it would then do is then take you to the marketplace. And from the marketplace, you'd have to find that resource, and then that gets you into the wizard flow. So just quickly showcasing that, right now we are inside of the Azure function, and as you can see, there's a create button that I can click, and when I click that create button, it's going to directly take me into creating the resource. You can see here, here's the wizard for doing that. Alternatively, I can go into the resource group and directly go into the demonstration resource and then click create from there. And this is going to take me obviously into the marketplace. And then from here, I can basically search for a function app. Now, this is an interesting view because you don't get this view when you go directly into the resource and create from there. This view presupposes that the resource could be coming from really anybody. So it's almost treating it like a shopping cart style experience where you have an overview of what the resource does, gives you some information about the plan, some description about it. You also look at usage data, so you can see basically who the publisher of the product is, the product ID, the plan ID that's specified. You see the category that it's inside of, and then finally you have the rating that you can specify for it. So let's go ahead and let's create it. So I'm just going to call it Think Mine Functions. Now we're going to change the name in a minute, but for now let's go with this. Next we can pick the runtime stack, and you see here that there are multiple options that you can select from. Obviously we're going to be using .NET, and you know that it can do .NET. It can also do Node, it can do Python, it can do Java, PowerShell Core, and then this last one here, custom handler. Well, what is that? Well, a custom handler basically allows you to use languages that are not supported by the function runtime by default at this time. So if you're using something like Rust or C++ or some new language, newfangled language or whatever that you've created, then you can use a custom handler to do that. The way it basically works is that your function app is sitting inside of the function app runtime. And when a request comes in for that event, if you're using a custom handler, it will basically pass that request over to a process that you provide that has a web server running on it. And that web server will interact with the function app service over HTTP, right? And then within that application, you can basically use obviously whatever language that you want. So it's a way for you to basically use the function app and use this capability, even if the technology that is being supported by the function runtime does not include the technology you have. Just build a web server, publish that web server using the specification that they provide, and you're good to go. So right now we're going to pick .NET, and over here you can see the choices of the different versions of .NET. You'll notice that there are only 2 items that don't say isolated on them. So what happened is that as of .NET 6, basically, um, every future version after that only runs in an isolated mode, doesn't do the other mode. So we're not even really going to talk about it. In this case, we're going to be using .NET 8. So the next thing that you have to choose from is basically the operating system that you're going to use. As you can see, your choices are Windows or Linux as of right now. And then on the hosting side, you have an option to use a consumption plan, to use the premium versions of the function runtime, or to use an app service plan. So what is the difference between those two? Well, the answer to that question really lies in how app services are set up as a whole and what they really are, right? So when you deploy something into an app service, let's say you have some code sitting right here and you want to deploy it into an app service, you always really are deploying it into something called an app service plan, which I'll call an ASP. And what is an ASP? An ASP is essentially, for all intents and purposes, you can think of it as a machine in a cluster. So by default, if you just create an app service plan and you only have one instance running, then basically it's one machine that's running your code. If you basically increase your instances, then your code will be replicated to every single instance. What does that mean for you? Well, basically, if you have a machine, then you're going to be concerned about memory, you're going to be concerned about the CPU, and you're probably going to be concerned about the disk or the IO, you can say. So when you select a traditional ASP, you specify these values yourself. When you select a consumption plan, Microsoft basically uses their heuristics to ensure that your application functions as it needs to function. And you pay for whatever CPU, memory, or disk is used to allow your application to work. So Microsoft is going to scale the application, or the runtime itself is going to scale the application as needed in order for you to satisfy whatever requirements you have and you're receiving in terms of like how your application is being used. The value proposition for a traditional ASP is that you have an understanding of the cost, right? You know how much it costs ahead of time. So it's going to be, if it's going to be, let's say you get a 8 gig of RAM and you have a 16 core machine and you've got 16,000 IOPS, you know that's going to cost you maybe $150, $150 a month. And that's good because you can do all your cost planning based on understanding that number. It can go up and down and different things, but generally speaking, that's going to be the cost of compute for this code that you have. The problem with this is that if you are using this application and you have it published and a lot of people aren't coming to the application, you're still paying $150, right? No matter what happens, you're paying that $150 a month. And let's say the inverse happens. Let's say that you get loaded with tons and tons of users that come in, where you've capped yourself at this amount for this kind of computer that's basically hosting your code. So when you hit that amount, the application will just stop performing as it should, and you'll start getting delays and things of that nature. On the flip side of it, if you are using a consumption plan, then if only 2 people are using your application and your Azure function has only been called twice, then you'll pay for it being called twice. If it's being called a billion times, then you pay for it being called a billion times. And of course, there are thresholds that you can set on cost to prevent it from overshooting. But basically, the value proposition of the consumption side of the house is that you don't have to pay for code that you're not using. So on one side, it's a use it or lose it. And on the other side, you have the advantages of being able to basically allow it to scale as needed to satisfy whatever your requirement is. So what we're going to do for now is we are going to pick the consumption plan. So I'm going to change the name to Think Mind Functions Consumption. And we're also going to then at some point go and create a normal one and see how that works. Function apps require the use of a storage account. So we're just going to create one. Let's just change the name here. Call it Think Mind Store or something like that. Think Mind Storage. It's fine. And then we'll go to networking. And then the networking side is the first place that you're going to see how your choice that you make in terms of using consumption or not starts to affect the things that you can do. Now, you're still able to access this application either publicly or privately, but you can no longer do network injection. So what do we mean by being able to access the application, the function app publicly or privately? And on the flip side, what do we mean by VNet integration or being able to integrate back into your enterprise? App services, once again, and Azure really sit in two domains, right? You have one domain which is platform as a service, and you have another domain which is infrastructure as a service. On the infrastructure as a service, you're talking about things like VMs, maybe firewalls, and other such network appliances, maybe containers, pretty much anything that you can plug a network cable into so that you can communicate with it within your home office or wherever you're located qualifies as infrastructure as a service. Now, for infrastructure as a service components to function, because you're sitting in a cloud somewhere, they have to be networked. So on the IaaS side, you also have this concept of a virtual network. Right. So this virtual network basically represents a software version of a physical network that you might have in your office or your home or wherever. And a network basically connects computers together using routers and all kinds of networking appliances, firewalls, and things of that nature to prevent people from accessing from outside. Typically, your virtual machines, your firewalls, your Docker containers, and all these things will sit inside of the network in something called subnets. Subnets are just basically small segments of the overall address space for a virtual network. So each of these areas is called a subnet, right? And each of these guys, any one of these guys up here, right? They basically sit inside of these subnets, right? They pick and choose. You can pick and choose which subnet that you want them to be in. So this is what's happening within your network. And typically your network will be somehow connected to the network that you have on-prem, so your home office or whatever, over a VPN. That's how it connects. So any computers that you have here, like maybe you have a database here, can communicate via the VPN into the cloud. And things that you have in the cloud on this infrastructure side can also communicate back into your enterprise through this VPN. So typically, this is sort of like when people think about the cloud as being a data center, this is what they're talking about, this side. The PaaS side is a little bit different because the PaaS side, platform as a service, is controlled by Microsoft. It's not controlled by you. You don't have any access to the physical servers that make up those components. As we saw with the app service plan and things of that nature, those servers are being created on the fly by Microsoft to satisfy the value proposition of elasticity. And what is that value proposition? Basically, it means that So if I wanted to add a new machine back in the days to my cluster that I've created, someone would have to go and order that machine. If I want to add a new VM or 10 VMs or 20 VMs, someone has to go and create that VM, even now in the cloud, and configure it appropriately with all the necessary software and get it going. If I need to reduce those VMs and take them down, even though it's a little bit easier than physical machines, someone still has to go in and remove those machines, derequisition them, get rid of them. It can be laborious to do that. So the idea of PaaS is that you forget about the VM, you don't think about the VM, and you just focus on your code. So basically, you will have these app service plans or whatever they are, these various utilities that mask the the relationship with the actual physical machine, and you just focus on the code part. This is the part that you focus on. Now, the problem with this infrastructure is that for this all to be facilitated, they have to sit in a network that's controlled by Microsoft, while this is really controlled by you or the enterprise. So one side Microsoft controls, the other side the enterprise controls. And these are not inherently connected to each other. On the VNet integration part of it, in that option, it's about allowing for your code to be able to communicate with resources that are inside of this network. And on the other side, because this is inside of the Microsoft code that's controlled by Microsoft, this is by default set up to be public. That means that any Azure function or any app service that gets created anywhere in the world is instantaneously available to anybody else in the world as long as they know the address to that resource. This, as you might imagine, can be sort of a problem for enterprises that want to use these capabilities, whether these app services, to facilitate some functionality inside of their actual environment, not out there for the world, inside here. Like if you've ever worked in a company and they had a SharePoint site, an internal SharePoint site, or some kind of intranet site where they had all kinds of information in, they don't typically want that to be exposed to the outside world. They want it to be so that if you're over here on your computer or your laptop and you want to access the intranet, you're not bouncing all the way out into the web, all the way around, all the way around to get there to access it. You should be able to access it by going directly through the VPN, through this network, out to this resource. So that's where the public and private comes in. App services will typically have some kind of capability. I'm not going to call it a firewall, but they have some kind of capability that prevents people on the web from being able to directly access them. So if I'm a browser or I'm some kind of application, if I try to access this guy, it's going to stop here. This is going to block it. It's not going to be able to get in. So even if I have the address for this resource, as an enterprise, I can still block the resource here with a pseudo firewall that basically prevents people from being able to access it. And of course, this firewall can be controlled by some kind of policy, right? That I can set to allow maybe this guy is allowed, but this guy is not allowed. So that's the other side of it. On one side, it's about how do I access my resource from the outside world, or am I allowing my resources to be accessed from the outside world? And on the other side, it's how do I, from my public domain app service, how do I make it so that I can communicate with internal applications, and how can I also make it so that internal applications can communicate with me? How do I provide some kind of capability in here, a proxy of some kind, a broker that basically allows for these guys in here to see me as if I'm there. They directly communicate with this broker, this dot that I have here, and then the broker shares the messages with me. So as you can see, this is not allowed for consumption plan. So that's the first problem that we're facing. The consumption plan is not going to let you do that. Even though the consumption plan does allow you to enable public access. So let's disable, we don't want app insights, and we don't care about continuous deployment. We've done this already when we went through and looked at app services, so we can ignore it for now. And then tags we're not setting, and we should be able to basically deploy this. As you can see, even though it's called a consumption plan, and even though we never specified an app service plan, if we go here and look, right, we can see that an app service plan has actually been created and that the SKU has been set to dynamic. So this app service plan is going to change. Your code is going to be allowed to be on different services, on different app service plans, based on the need and demand that's coming in. And this is all the heuristics that's controlled by Microsoft. So let's go ahead and let's create it. All right, and that's done, and we can see that it's there. So let's now create the other one that's going to represent just a normal app service plan Azure function. So again, we pick .NET as the SKU. And this time we're going to pick app service plan. And immediately you see that when we pick app service plan, some new things are appearing, right? We've got this ability now to select the plan that we want, and I'm just going to call it Think Bind Plan. And then we also have this ability to pick between different versions of the app service. So this is what we discussed when we said that even when you're creating an app service, you still have to define compute. You still have to pick the kind of machine that it's going to sit in. Now, unlike a normal typical VM where you're just selecting the VM and doing all that stuff, you don't do anything else, but you do still have to pick the compute that you're going to use. And then the other thing that you'll get with this now is you'll get this notion of zone redundancy. So you don't have that with a consumption plan, but you'll get it with the app service plan. So what is zone redundancy? So as you know, Azure would be broken up to different regions. So you will have East, and maybe you have West. And within each region, as described by Microsoft, you would have 3 data centers. Now, in the last video that we created, we showed you that when we deploy the app service, we set zone redundancy. We select a premium plan and set zone redundancy. And what happened when we picked zone redundancy is that it actually put our app or our app service in each of the zones. So by default, we started with 3 instances, which we immediately had to start paying for. So the value proposition of zone redundancy is that you get redundancy, which means that in a data center, if that data center goes down within that region, you still have 2. If this goes down, you still have 1. If you didn't have that, and you just set up your app service so that your app service was just on 1, let's say I got rid of that and I got rid of this, then if this guy goes down, your app service stops functioning. So the value proposition for zone redundancy is basically to get full resiliency for your application. And I would recommend that you look at the numbers, the availability numbers that are published by Microsoft, because I'm sure those numbers will change over time. So the easiest way to get the availability zones is to basically switch to premium. They do not work in standard, but we are going to use standard for this particular demonstration. So go over to storage, and we've already created a storage account, so we can just use the storage account that we created. And then over here, when we get to networking, you should see now that enable network injection is available. And you can see that when we actually enable network injection, that basically you're able to select the network that you want to connect to. And that's what we showed in that demonstration earlier. I'm going to turn that off for now, and I'm also going to turn the public access off. We don't need app insights, and we don't need any deployment. So we're pretty much done. So this is all loaded, but it doesn't look like it's showing up now. So let's just refresh this guy so that we can get it. There we go. So as you can see here, we are in the demonstrations resource group, and here is our storage account. Here's the app service plan that we just created. Here's the consumption version of our Azure function. Here's the normal version of our Azure function. And here is the app service plan, as you can see, that was created for the consumption plan. So even though it's a dynamic consumption plan, it's still an app service plan. So if we go in here, we can see that we are able to do VNet integration, set up hybrid connections. We can scale up, which is basically we can swap the different versions of machines that will be allowed. And you can actually see right here, it tells you where you're at. So you can see the SLAs for each one of these and what they are. You can see that the free version has no SLA. Why is that? Because it's only 60 minutes a day. So theoretically, your Azure function, if you're only getting one call a day and it's a consumption plan, you may end up not paying anything. I don't know if it drops down that far, but it drops down pretty far, right? You have the shared one there. It's the same thing. And the basic is about 54 bucks a month by default. Scaling out is the opposite. On the scale out side, that's basically adding more servers to your cluster. So as mentioned, no matter what happens, an app service plan, you can think of it as a cluster. So as you scale out, basically what does it mean? It means you're just adding more machines to the cluster. But conceptually, your code is still going to sit here, and it's just going to get replicated to the other machines that are inside the cluster. There are two ways to scale out. You can do a manual scale out, which I just showed here, or you can do a rule-based scale out. The rule-based scale out will use schedules or CPU, memory, those kinds of things to determine whether or not it should scale out to meet a demand. You can imagine that if, for example, between December 1st and December 31st, your traffic goes up by 1,000%, then you can set a rule to just scale out to 10 instances during that period of time. Or maybe if you get a spike and you don't know when you get that spike, you can't be very sure when those spikes happen. Then you can say, maybe use your CPU and say, hey, if my CPU hits goes over 70% or 80%, then just spin up another one and distribute the load between the two. Comparing that to the dynamic one, you'll immediately notice that the networking, scale up and scale out are disabled. You can't do that because it's being done for you. The next thing we're going to do is let's go ahead and let's test out these applications and actually browse to them and see what happens, because remember that they have been blocked, right? I set up for each one of them. I don't have public access to them. So if I click the link, what should happen is that absolutely you get it forbidden, and you'll get it forbidden for this. And if you go to the normal functions app, you will also get it forbidden because it's being blocked by that firewall that I showed early on in the video. Let's click on that, and you can see that you don't have the ability to access it. So now let's go ahead and let's create something that's basically going to allow us to do that communication that we've talked about. If you remember from what we demonstrated, we have two sections, and we have our network sitting here, which is broken up somehow into all these different subnets. And then over here, we have our PaaS service that's sitting inside of an app service plan. And there is not clear, there isn't a direct connection between these two environments. There is a connection, but it's not a direct connection that's just native to how these services function. So we need some capability that allows for this guy to sit inside of here, and on two fronts. We need one for when people want to access this guy, and then we need one for when this guy needs to access resources inside the network. These are two separate concerns, not the same concern, and there's two technologies that can be used to achieve them. So the first thing we're going to do is we're going to create what's called a private endpoint. And again, this goes through the same pattern that we went through before. You look through the plans, look at the usage information and support, and then basically ratings for it. Let's go ahead and let's create it. And I'm not going to go and create this whole thing all the way through, but I do want to create it so you can once again understand the distinction between the consumption app service plan and the standard app service plan. So we can give this a name and make sure it's in East. And now the next section is where we need to select what resource we are creating this private endpoint for. Remember, this private endpoint is going to basically sit inside of our network and serve as a way to broker communication between resources in our network and resources that are in the PaaS side of it, right? So it allows you to communicate between IaaS and PaaS through the internal network, not over the web and the public network. Private endpoints satisfy the inbound communication into PaaS, inbound into PaaS. Right. While the other approach, VNet integration, satisfies the outbound from PaaS into your network. So when you set up a private endpoint, you're wanting to set something up so that the other services that you have, the laptops in your on-prem environment, any servers you have in your IaaS network, that they can all access your resource via a network IP address, as if it was within the actual network, as if it was an IaaS resource. So we pick the resource type that we're looking for, and we're looking for a web. Let's select that, and then we can pick from one of the items we have. So you can see when you pick web, it shows you all the web-based resources that are there, and you can see over here that within the demonstrations resource group, we've got the ThinkMine function and the ThinkMine consumption function. So we'll start with ThinkMine function, and as you can see, everything goes about perfectly fine. It actually can create that resource. And if we go over to the network, over here, you would pick, remember we had that diagram of the full network, and then we have the subnets that are inside of the network. So the first thing you have to do is you have to pick the network, right? So that's the virtual network. We can call it VNet. So you select what VNet you're using, and then let's say these are the names of the subnets 6, 7, and 8. Then you also need to select what subnet you want to use. You say, hey, I want to use this one. So I want to use VNet 1, subnet 2, like that. So you pick that here, pick the VNet, pick the subnet there. And then down here, you can also decide whether or not you wanted to just select an IP address for you, your standard DHCP, or you want to pick a static IP address that you actually want to use. We'll talk about application security groups at a later date because it's a much bigger topic than what we're focused on now. So for now, we don't need to worry about that. So let's just go back here and let's look at what happens when we actually pick the consumption plan. So as you can see, when you pick the consumption plan, it basically doesn't work. There's no sub resource. It does not work. You're not able to pick it. So the immediate value proposition of an app service plan versus a consumption plan, from the perspective of the app service plan, is that with the app service plan, I can treat my service as an internal resource. You cannot use a consumption plan at this point in time to build intranet-based resources that are not going to be exposed to the external world. If you need to do anything like that, you're going to have to scale up to using a standard app service plan. So now that we understand how this all works, let's go back and let's enable the ability for public access to our resources, because ultimately we're going to need public access so we can test it out, because we don't have a network right now. So we can go in here and we can choose between disabled, enabled from select networks, or enabled for all networks. So what is the difference between that? So we already know that our PaaS environment is going to be sitting out here, and we already know that this item is going to be here. We understand what's going on there. And we know also that basically we've blocked traffic so that the outside world cannot actually get to it. In this scenario, what if you still wanted people to be able to access this resource, especially if you're a consumption plan and you don't have the ability to add any capabilities to this resource in order to allow it to live inside of the network? Well, what you can do is you can tell this firewall, if the traffic comes from one of these networks that's inside of here, like let's say, hey, if it comes from here, then let it through. So it's kind of a pseudo private, because the traffic does not necessarily navigate through the backbone of Azure. The traffic is still sort of going out into the cloud or into the web. And then while it's out in the web, it's coming back in. And then when it comes back in, it hits the firewall. And because the traffic has indicators that identify the network that it's coming from, and because Azure understands that this firewall can query to see that who the sender is and know that it's here, it will actually allow it through. It'll allow this traffic all the way through. So that's kind of what's happening here. It's not necessarily going directly in this way, which is really what we want, and bypassing the firewall. It's still hitting the firewall, so it's still really coming from the outside world. So you can see here that this is where you would then pick whether you want to allow or deny it. Here's all the rules, basically the policies that you have associated with it when this is selected. And then alternatively, you basically can enable all networks and all traffic. This basically makes it public. This is how it is by default when you actually start the application. And we can do the same thing now for our ThinkMind functions. We go here and we basically enable it. So now that we've enabled it, we can now go and actually browse to that site, and we should actually see something show up. There you go. That indicates that the function app is running. This means it can be accessed. That's not an actual web page. It's just the way the function app renders, but it's not something that we're going to find a static web page that represents that available to us. So now that we have that done, let's go ahead and let's delete the consumption plan piece of it, because we're really not going to be using it any further. Deleting services in Azure is relatively straightforward. You just check it, you click the delete button, and then you'll have to type in delete to say that you're agreeing to delete it, and then it just wipes it. Pretty straightforward. So now that that is deployed, let's go in and let's just go through all the capabilities of the Azure function. At the highest level, you have basically all your data about the function, the app service plan that it's in, the operating system. You can configure health checks. You have the actual URL of the app service plan. You have the version of the runtime that it's running. Obviously, you have your subscription here and the name of it, the location, the Azure region that it's running on, the status of whether it's running, and the resource group that it's a part of. Down here, you'll have all the actual functions that you have enabled. Right now, you don't have any functions in the function app. An Azure Function App exposes each one of the functions by themselves, and you can manage each function by itself. That's a huge advantage over using technologies like Web API, where basically once you publish this out there, you can't turn individual services on and off when it's actually running. With an Azure function, you can actually disable certain functions and enable others. So the big thing to start out with is the activity log. This basically tells you everything that's gone on with your actual resource. Identity and access control, the IAM, this is where you set all the permissions associated with the resource. This is where if you need to add new roles and give people permissions to use the resource, you do it all here. Tags are pretty straightforward. Basically, they just allow you to apply metadata to your resource, so it's easy to search and find. You can use the diagnose and solve problems to diagnose and solve problems, pretty self-explanatory. Windows Defender for Cloud can be used to analyze your service or your resource to make sure that it meets all the requirements for being secure and healthy. And then of course you have your events, and we looked at these before. You'll notice right here, so here's one of the cool things about Azure Function when we say it's event driven. Here's a perfect example of it. For events, you can actually use an Azure function as one of the ways to receive that event and to do something with it. So if I create a new subscription right now, and you'll see that the event types that could be filtered on include quite a number of things. When the app is updated, when a swap slot is started, when it's completed. Each one of these events here can trigger an Azure function to either log that event or do something, right? So if you want to build really automated, highly resilient, very elastic systems, cloud-based systems, you can't beat Azure functions because they really are sort of like the native way of sticking everything together. They're the glue of the Azure portal. So we're not creating anything, so let's close that. Let's move on to the next thing. So app keys basically represent a way for you to control access to your application. By default, if you create an Azure function, people will be able to access it. Right, so going back to this example, this time we're using an application, and over here we have our app service plan. Of course, we have our Azure function inside of it, and this Azure function is exposing, let's say, an HTTP endpoint for test. 1 and another HTTP endpoint for test 2, so that this guy, if he requests get test 1 / test 1, something like that, it'll go here. If it's test 2, it'll go there. And as discussed before, the functions themselves can be individually managed, so you have that capability. When you set up an app key for your app, what it does is it says, well, if I have this other guy here, let's say this is a Tesla, and the Tesla wants to access my test data for test 1. If the Tesla doesn't have a specific code, a URL query string encoded into the request, then it will fail. And the query string is basically code, right? And then in here you would have that app key that's specified. So when the app key is specified, and the function that you deploy says that it wants to use app keys as a way to secure it, people will not be able to access it. But this is all dependent on the way that the functions are themselves deployed. So application files basically allow you to make some modifications to the files associated with the application while it's sitting on the cloud. This is sort of redundant because, again, this file that you're looking at right here, that file is available through Kudu and the app service editor, so you don't necessarily need this capability to be here. You can just edit it the one standard way that you specify. Of course, Azure Functions also support deployment slots. This would be the same as any app services deployment slots. They basically work the same way. And they support deployment, right? So you can basically use all the usual suspects, whether it be GitHub, Bitbucket, you name it, Azure repos, whatever it is, you can pull the code from there to use to deploy it. In the configuration section, you have this section here where you can specify configurations that your app can read and use to do whatever it wants. And then you also have function runtime settings. This is to select the version of the function runtime. And then finally, you have general settings, which you can use to basically pick the version of .NET or the processor, CPU, kind, and whatnot can all be picked from here. There's a lot of things that you can do in this general settings. You can switch between whether you want isolated or not. You can switch between the pipelines that you support, the version of HTTP that you support, the TLS version you support. Just go in there and check it out. We previously looked at authentication. If you haven't watched my video on app services, watch that video because we go in and talk about authentication, so I won't talk about it here. App insights we're not using. That's a big topic around logging that we will save for a different day. Again, I have a video on app insights. Go to my channel, check it out. Like, subscribe, share. Identity is a way for you to manage the identity that your Azure function will use when interacting with other services. Again, in my video on app services, I go into this. Because this is an app service, all the videos that I'm going to do about all the various app services, websites, Azure Functions, Logic App, API management, they're all going to have similar things. So watch the app service one because that really gets a little bit more into this, and that'll help you understand how identities work. And then I'm going to do another video on identities as a whole, just to show how to interact between services using identities. Backups, allows you to back up your site content. Custom domains. So by default, everything is going to have the Azure websites.net, and then whatever you have, whatever you called your Azure function is going to be here. Now, there's a couple of problems with that, which you'll see in a second. The first one is that because everything is under the AzureWebsites.net, and because Azure is defaulting as always to HTTPS, basically there's a wildcard cert star.azurewebsites.net that represents all sites by default, all sites around the world by default. So be wary of that and basically ensure that you create a custom domain for your app services. So going down here to search, you can see that's what I'm talking about. You can add the search that you want. You got the ability to bring your own, and you can actually buy these, by the way. So you can actually buy them now from Azure, and they have a partnership with GoDaddy, and they take care of that. The networking, we've already seen this, nothing special here. This we also saw in our app service video, so sorry to keep saying the same thing, but watch the video. These are the outbound addresses that you will need if your service needs to be whitelisted. If your service calls out to other services or anything that's HTTP based, these IP addresses could be the IP address that your server is actually coming from. So that's the list you have there. Here's the virtual network where you can set it up. There's also a whole bunch of things that we'll talk about when we do our networking video, like the NAT gateway, network security groups, those kinds of things, and Azure Front Door as well. Here's the inbound IP address. So if you use this IP address, you'll access it. Again, we talked about this in our app service video. You still need a host file. You can't just provide the IP address. So you still need a host name, but that host name will resolve to this IP address. And of course, you can specify the private endpoints associated with the resource. And of course, you can disable or enable public access. So that was previously not refreshed, so I just refreshed it and I can see now. I just noticed that public access said disabled. It should not say disabled, it should say enabled. So the next two things, scaling up and scaling out, we've kind of dealt with before. You know how it all works. In fact, we talked about it quite a bit before, but scaling up basically allows you to switch between the services you want to use. You can switch up and you can switch down. Be careful how you do this, because a lot of times when you go up to a certain capability, it won't allow you to go down because there would be obviously service degradation if you were to go down. So if you already have zone redundancy enabled, then you won't be able to drop down to a SKU that does not support that. You'll basically have to recreate the service all over again. So just be careful. Scale out, we also talked about. It's basically the opposite. It allows you to do horizontal scaling. Properties, these are all the properties associated with your resource. Nothing special here. This is basically what's in the landing page for your resource. Locks, watch my demo for app services. We talk about locks. It allows you to basically lock a resource so that it can't be modified. There are multiple ways that resources are modified on the cloud. There are IAC scripts, there's RESTful calls, there's the portal, there's consoles, there's so many different ways. So if there's a resource out there that you don't want to be modified, you can put a lock on it and that will prevent it from being changed. App service plans, we've talked about ad infinitum. And if you recall the metaphor that I like to use where I say an app service plan is basically a server in a cluster or a Windows or server cluster of some kind, note that when you go into app service plans, you start seeing things like memory percentage, CPU usage, data in, data out, things like that, that would be indicative of what a virtual machine would be seeing. Quotas, we're not going to talk about, as stated earlier. We'll save that for another topic. And changing your app service plan. Well, why might someone want to change their app service plan? Well, the interesting thing about app service plans is that because they are basically a server that's part of a cluster, and you add your code to it, and here's my function app, You can add other things to it that are also app services. So this might be a website, right? And here's a function app. And this might be another function app, or maybe it's a logic app. But let's go with another function app, right? But this particular function app is using maybe 50% of the resources. This is using 30% of the resources, and this is using 5% of the resources, right? That's how it's set up. So in a configuration like this, I might say, hey, I'm gonna take this function app right here and I'm gonna move it into its own app service plan, right? And maybe now, because it's in its own and it doesn't have all that resource contention, it's down to 40%. And this now frees this server up so that it's not pegging constantly at 85%. It's now as a whole at 35%, and this guy's at a whole at 40%. So you can do things like that because basically, again, they are a server in a cluster. So you move them around, move your code around, change the app service plan that your code is going to be able to run on. It's your choice on how you want to handle that. So this now goes into the deployment tools and development tools. So obviously here you can create a console. You can use the advanced tools, which is Kudo, or you can use the app service editor. They basically work the same way as they would work with a standard app service that was hosting a website. So when we go into the console for the created function app, you can see that these are all the things that are in there. Here's all the information. And there's that host.json file I was talking about. That's there anyway, so it does not necessarily need to be exposed. Of course, it's a fast way to look at it, but basically, to me, there should be one convention and one approach to doing this, and not a whole bunch of other different ways. But you can do the same kind of navigation that you could do with Kudo when you were using, or Kudu when you were using an app service. Basically works the same way. And of course, you can also use the app service editor. The big difference right now between the app service editor and Kudu is that you can actually create files with Kudu. You can't create files right now with the app service editor, but you can edit anything that's in here. And and on Kudu you can't edit. So it's a little bit, if they merged it, it would be great. And there again, you see the host.json file that you can edit. Extensions are basically allow you to extend your app service with some capability or another. Nothing new there. And then we go into API. So API management allows you to basically connect your app service to an API management interface. If you don't know already, I'm going to be doing a video on API management, but in general, it's just a front end that sits between your service and your customers or whoever is consuming your service, and allows you to proxy that communication so that whatever you call your services and the endpoint that you have inside of your enterprise don't necessarily need to match what's exposed to the outside world. If one is created, you can use it, or you can create one here. API definitions allow you to attach a swagger to your APIs. CORS basically gives you a mode of control for callers that are coming via some other web application or website. You can specify any host that you want here to allow them to access your service, or you can say you want anybody to be able to go in and then anybody will be able to use it. So it just gives you more controls. So going into monitoring, alerts basically allow you to alert based on different criteria in your application. The signals are For example, server errors, check status, response time, and there's a bunch of them. And then based on thresholds that you set here, it can determine whether or not to send an email out, create actions, and I believe you can even use it as part of the automated scaling that app services use. Not much special about metrics, advisory recommendations, health checks. Basically, you can specify a URL that you want the service to call to ensure that your application is running, that all your application needs to do is return a 200. And all the log related things we're going to leave for our log video. That includes diagnostic settings, log streaming. When we tackle it in our larger logging video, we'll get into the details of all this stuff. Now on the task side, we've seen this before. This is basically for Azure Functions. All you can really do is send a monthly billing report. Then finally, you can export the template. This will create an ARM template, which essentially is IAC, infrastructure as code, that can be used to deploy the resource in an automated manner. Resource health just checks the health of the resource and just reports it of this particular resource. And support and troubleshooting gives you a mechanism that you can use to troubleshoot if you have issues for the resource. So with all that done, let's go ahead and let's try and actually deploy some code to the application. And we will follow the same pattern that we did when we created an app service, which is basically create a new file in Kudu inside of dub-dub-root. And we can just call this file, I don't know, test. It's called test.html. Okay, and now we can go over to the app service editor and we should be able to add some code in this. And if you recall, when we did this with an app service, basically an Azure website, it immediately served. And you'll see here that that's not going to be the case. So go in here and have that in, and that fails as expected. So how do you deploy your code into an Azure function? Well, there's a couple of ways that you can do it. You can see that there's two approaches listed here, and the IDE that I'm going to use to do it right now is my old favorite of Visual Studio. So let's go ahead and open that up. And we are going to select Azure Function as the resource type that we want to create. Specify the name. We can use the same name as what we used previously, so think mine functions. And over here we can see that we have our option to specify the version of .NET and the function worker that we want to target. And we also specify for the function that's going to create, it's going to create a default function, what kind of trigger we want it to use. And then over here in the authentication level, we can select whether or not we want no authentication, we want the function authentication, or we want admin. So that lends itself to that app key thing that we talked about earlier. When you have the function authentication in place, what you're doing when you create the function is you're saying, hey, I want the app key to be used before I respond to a request. If you don't have that enabled, even if you have app keys, it's not going to make a difference. The function app will go through. And of course, we're going to switch that to .NET 8. And we have the HTTP trigger, but there are numerous triggers which we previously showed. Right, so you've got Event Hub, you name it. There's so many different triggers that you can choose, and there's even ways to create your own trigger, honestly. Right, so that gets created. Now we have our Azure function, so let's run that. And then we should be able to test that by clicking on the link here. Let's try this. Click it again. There we go. And there you have it. It has been created. So one thing that you can do to test your application if you don't want to use just clicking the link is you can use an HTTP file. And I have a video that talks about this, but you can just create a simple file with a .http. You can see here that it's actually listed as well, but we're just going to create it from scratch here just to show how easy it is to create and that it really doesn't matter. It's just a text file that's treated a certain kind of way by the user, Visual Studio, what have you. To get going, we just paste the URL. So we're just saying the command we want to get this function from here. And once you stop it, I just stopped the application. So I'm going to try to run it. It's not going to start the application because I'm running it. So you're going to get an error for me to actually use it and get the right response. I actually have to run the application. And now when I click the link, there you go. It's going to show me welcome to Azure Functions. And now that we have that working, let's go ahead and let's publish it. So pick that. And should be done. Now we can just click on publish to send it off. And there you have it. It's fully published and available. So what happens now that it's published if we want to call it? Because previously we were calling it in development mode locally on our machine. Now that it's running on the cloud and we specified that we want it to have that we want the functions themselves to be authenticated before they can be used, we should get a different experience. But before doing that, let's open up the editor and see what exactly was uploaded onto Azure. And you can see that it's very, very different than what happens when it's a website. It's full of tons of DLLs. Azure Function Apps are a different thing from websites. So we got that out of the way. So let's now go ahead and let's test this out. And you can see that when I go to the overview, remember that thing, functions that had nothing? As you can see here, the function that we created is now showing up and it's actually given the name function1. So you have a lot of granularity here. It can be individually monitored, individual status, the kind of trigger that it is. It's all specified here. Take that URL and let's go back here. Let's see if we can swap this out, if this will work. And of course we know it's not going to work, but let's just go through it so we're being comprehensive. Now when I do this, as you can see, it's failing, but the way it's failing, we can't exactly see what the problem is. So why don't we try to use the HTTP file, because if we're using the HTTP file, we'll actually see the responses. Visual Studio shows all the responses associated with it. We can go here and we can add a new entry by using the triple pound mark between each one of the requests that we want. A second here. Go. And now let's click that and see what happens. And here you can clearly see what the issue is. The status is unauthorized access. And why are we getting unauthorized access? Because we're expecting a code that's not there. So let's go fetch that code and use it. So we want to go over to app keys. And and we want to look at this default down here. Copy that. And then we want to go here and we want to specify it. Again, remember, we're going to do question mark because it's a query string, code, and then equals, and then we're going to put in that key right here. That's how it should be. Perfect. And now let us run that. And that's it. Azure Functions are a great tool to use to connect various aspects of your enterprise. From event monitoring to building API applications, you really can't go wrong with this unique kind of app service. Now, we just hit 50,000 subscribers, and as part of a thank you to you all for helping us get there, we're going to be doing a whole nother round of giveaways. In order to qualify, you do have to be subscribed to this channel and follow me on X for further details. You can find the links to X and all my social media below, so please come over there and join the conversation. You'll have a chance to win another Lenovo YogaBook 9i. We also have a Pixel Fold available and various other cool gadgets, devices, and everyday swag. Until then, we who are about to code salute you.